Hello, students. Welcome to KENE'S Educare, a group of KENE solutions. This is part 3 of lesson Is Matter Around Us Pure? So as we were studying about solutions, right? We studied about what exactly mixtures are. We studied on what exactly pure compounds are. We studied on what exactly solutions are, and we studied on what are solutes, what are solvents, what are distilled solution, concentrated solution, diluted solution, right? We have studied all those concepts in part 2 if you all remember. So before I proceed further, I want each one of you to please revise whatever note you have taken in your book, because there was too many things that you have written. Even we have studied on the properties of solutions, which are the different types of solutions, and there were 2 3 group activities where we were divided into 4 different groups and we were studying it like that way, right? So I just want each one of you to please go through whatever you have written in your book till now. I hope everyone is revising whatever you have written in your book. So I'm going to show you all the slides one by one, and I want you all to please go through the slide, and if you have missed on any important points which you have not taken down in your book, I want you all to please take it down. Okay? Okay, so here we had like on first slide we had information on pure compounds. So I hope now you are very much clear with the term. What does this pure ghee and pure milk means? It means they are made up of only a single type of particle. Okay, whereas if I say any substance is a mixture is going to have considerably like two or more pure components which will be mixed together, right? So the example over here includes seawater, mineral, soil, and there are so many you can say type of mixtures that we have, right? After this we discussed on what exactly mixtures are. So I want each one of you to please go through it once. I hope everyone is going through the slide. After this, like after discussing on what is a mixture, we discussed on the types of mixtures, and like we discussed the type of mixture through an activity where we had a group, you can say a group discussion in detail, right? So I just want each one of you to please go through this activity once. I hope everyone is going through the activity which has been given over here, where we are going to divide the class into four groups: Group A, Group B, Group C, and D. And we have like provided all the groups with different, you can say, components, right? So, Group A students are going to like take 50 ml of water. Along with that, we had like one spatula full of copper sulfate powder. Okay, group B is going to have like is going to take 50 ml of water, and along with that two spatula full of copper sulfate powder. Okay, then group C and D will have different amount of copper sulfate and potassium permanganate. Okay, group C and group D, they are going to take different amounts of copper sulfate and potassium permanganate, and they're going to form a mixture of it. Okay, and then all of them are going to observe it, like they are going to report the observation on uniformity in color and texture. Okay, and after performing the activity we have to check the results and observe the results of all the four groups. Okay, so I just want you all to please go through it. So after this, like we had one more activity, right? 2.2, where again we were doing a group activity. So see, when you do it in school, you will enjoy the activity if your teacher takes you to the lab. Okay, so this is the activity that we discussed, and here we studied about filtration as well, that using a filter paper, you have to like make a cone of filter paper, and then whatever solutions that you have, you just have to pass it through the filter paper and then check whether any residue has been left in it or not, right? So what we have to do is, like we have to, again we divided the class into four groups like A, B, C, D. Then group A will have few crystals of copper sulfate. Group B will have one spatula full of copper sulfate. Group C will have chalk powder or wheat flour, and group D will have few drops of milk or ink. So this is how, like using different compounds or mixtures, we made a solution, and then we are going to check it using this filtration technique. So when we do this activity completely, we'll find out that group A and B, which had like copper sulfate, they have got a solution. Group C, which had chalk powder or wheat flour, they has got a suspension. And group D, which had few drops of milk or ink in it, has got a colloidal solution. Okay, so I just want you all to please go through this activity once. I hope everyone has been through this activity. Then we discussed on what exactly solution is, right? So solution is a homogeneous mixture of two or more substances. Okay, so here we have, like we come across so many solutions in our daily life, right? We have laminate, soda water. These are all examples of solutions that we have, right? So the solution can either be a solid, liquid, or a gas dissolved in it, and here we have few examples of it given. And how can you define solution? A solution has a solvent and a solute as its component. Okay, so the component of the solution which dissolves the other component in it, we call that as solvent. Okay, what I said, a solution is going to have a solute and a solvent as its component. So the component of the solution that is going to dissolve the other component, that is called as a solvent, and the component of the solution that is dissolved in the solvent is called the solute. Okay, so here we have the definition of solute and solvent which has been given. Then we discussed on diluted solution, concentrated solution, and saturated solution, what exactly they are. So I just want you all to go through this slide once. I hope everyone is going through it. After this, we discussed on some of the examples of solutions. So I just want each one of you to please go through it once. After that, we discussed on the properties of solutions as well, right? So I just want each one of you to please go through this properties of solutions as well, because like we will be like we have one more part on solutions to discuss, and then we will be ending with the solution part, and we will study about you can say the next thing that we have is suspensions and colloidal solutions. Okay, but before that I want you to be clear with this properties of solution. I hope everyone is going through it, and also the examples which have been given for homogeneous mixture over here, which includes like coffee, wine, air, brass, steel, natural gas, vinegar, blood. These are all properties of solution that we have. Okay, so I just want each one of you to please go through it. After this, now we are going to discuss about the concentration of a solution, like what exactly concentration of solution is. Okay, so it is the amount of solute present in given quantity of the solution. That is what we know it as concentration of the solution. Okay, so how will you define concentration of solution? It is the amount of solute present in given quantity of solution, and the solution having small amount of solute. Now if the solute concentration is in less quantity, then we know it as dilute solution, and the solution having large amount of solute in it, then we call it as concentrated solution. And that is why we say that we can like work with dilute solution, but it becomes riskier to work with the concentrated solution, right? Because the amount of solute in it will be more. So you're like, if you have to define concentration of solution, it will be like the amount of solute present in given quantity of solution. Okay. So now here we have the definition of concentration of solution. Then what is dilute solution? The solution having small amount of solute in it is dilute solution, and the solution having large amount of solute in it is concentrated solution. Okay. So you can see like the dilute solution that we have is like weak and unsaturated. Then just beside that we have the concentrated solution which is strong, right? So what are we doing? Because we are making it concentrated, it need to add more amount of solute in it. So we are adding more amount of copper sulfate in that solution. Okay. And the third one, if you can see, that is saturated solution. So here in saturated solution, it will have more amount of, you can say, copper sulfate solution in it. Okay. So I just want you all to write the definitions of what exactly dilute solution is, concentrated solution is, and what is concentration of solution. And even you can draw this and keep in your book because it is going to help you a lot. Don't keep on drawing it with scale and all, okay? Just draw a rough thing with a but it should be well labeled as well, okay? So I hope everyone is writing the definition of all. Now, if I tell you like later about, if I just come up with the word concentration of solution, you should be knowing what exactly it is. It is the amount of solute present in a given quantity of solution becomes the concentration of solution. Then dilute solution will have small amount of solute in it. Concentrated solution will have large amount of solute in it. Okay, getting my point, everyone? I hope every one of you are now clear with it. After this, now we have an activity to discuss. So see, what you have to do is take approximately 50 ml of water in two separate beakers. Okay, what you have to do, you have to take two separate beakers and you have to add 50 ml of water in it. Then after that, add salt in one beaker and sugar or barium chloride in the second beaker with continuous stirring. Okay, so what are we going to do? We are going to take two beakers, taking 50 ml of water in it. In one of the beaker, I'll add salt. In the other beaker, I'll add sugar or barium in it, barium chloride. Okay. And when no more solute can dissolve, so I have to continuously keep on stirring it. And there will be a time where the solute will not be able to dissolve. So in that case, when the solute is not dissolving, when you are continuously stirring it, we are going to hit the content of the beaker so that the temperature can raise by 5 degrees Celsius. Okay, and then start adding the solute again. So if I tell you, I don't know if you are able to imagine this or not. Just imagine taking two beakers in front of you, adding 50 ml of water in each. Then you are adding you can say adding one salt in one beaker and sugar, or if you're not having sugar, you can add barium chloride. Now, so sugar is easily available. So we'll take sugar in the other beaker. Okay, and we have to continuously stir it. So there will be a time where you will see that the salt and sugar will stop dissolving in that case. At that time, we will start heating the content of the beaker so that we can raise the temperature of the beaker by about 25 degrees Celsius. We'll do that. And then we will start adding the solute again. So this is what we need to do. Okay. After this, see, is the amount of salt and sugar or barium chloride that can be dissolved in water at given temperature the same? What do you think when you do that activity? Adding salt and sugar or barium chloride will be the same. So at any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving, it is said to be a saturated solution. It means the solution is telling that now it's enough. I cannot add more amount of, like, I cannot dissolve more amount of solute in me. So that solution, we know it as saturated solution. And in other words, we can say when no more solute can dissolve in a solution. Okay, when no more solute can be dissolved in a solution at a given temperature, that solution is called as a saturated solution. Got my point? Now they all like, as a human you also have certain capacities, right? Same way the water is going to have some amount of capacity till which it can dissolve any of the content in it, right? But after that limit, what happens, it becomes like it cannot dissolve more amount of solute in it. So that solution, we know it as saturated solution. Okay, and the amount of solute present in the saturated solution at this temperature. So whatever amount of solute that you have added till the solution becomes saturated, that amount of solute, we know it as its solubility. And if the amount of solute contained in a solution is less than the saturation level, whatever amount of solute that you have added in the solution, if it is less than its saturation level, then we call it as unsaturated solution. So we have two different types of solutions to discuss over here. One is saturated solution and the other one is unsaturated solution. Got it, everyone? What exactly they are? Now see, what will happen if you were to take a saturated solution at a certain temperature and cool it slowly. Now just imagine you are taking a saturated solution at a certain temperature and then you are going to cool it slowly. So in that case, you can come up, like, from the above activity, you can come up that different substances in a given solvent have different solubilities at same temperature. So if I'm having many substances with me in a given solvent, they are going to have different solubilities at same temperature. Okay, so the concentration of a solution is the amount. Now the amount can be measured in mass or it can be measured in volume. So concentration of solution is amount of solute present in given amount of solution. So whatever amount of solute is present in a solution, we know it as concentration of solution. And there are various ways how can we express this concentration of solution. So we have three different ways, three different methods to calculate that. Now you can see the first method as calculating mass by mass percentage of a solution. What exactly it is? Mass by mass percentage of solution. So we can calculate that by mass of solute divided by mass of solution into 100. Now it is mass by mass percentage. Then second one is mass by volume percentage. This is also going to remain the same. Here also we have the formula as mass of percentage, mass of solute upon mass of solution is equal to into 100. Whatever value that you get, you have to multiply by 100 because we are calculating the percentage. Okay. Then volume by volume, again the same thing. It's just that it will become volume of solute upon value of solution or volume of solution. Whatever answer you get, you have to multiply by 100. And the reason for multiplying it by 100 is because we are calculating the percentage of the solution. That is why we are multiplying it. Okay. So I just want you all, like, there are so many important things. I want you all to write about saturated solution, to write about unsaturated solution, to write about the concentration of the solutions, and these three different methods of expressing the concentration of solution. I hope everyone is writing all the important points from screen. You have to even write the methods that we are going to use to calculate it. Okay. I hope everyone is writing it because all the definitions are very important. After this, now see, we have an example to study as well, where they have given us like a solution contains 40 gram of common salt in 320 gram of water. Calculate the concentrations in term of mass by mass percentage of the solution. Now we know how to calculate mass by mass percentage of solution. So for that, we will be like using the formula as mass of solute upon mass of solution, and whatever answer that you get, you have to multiply by 100, right? So see, mass of solute given is 40 grams, that is of salt, and mass of solvent. Now first thing that you have to do when you get a question, you have to identify which is a solute and which is a solvent. Okay, then you have to write that mass of solute, that is of salt, is 40 grams, mass of solvent, that is of water, is 320 grams. Okay, now we know that mass of solution is equal to, how will you calculate that? Because you have to calculate mass by mass percentage, right? So the formula will be like, for calculating the mass of solution, it will be like mass of solute plus mass of solvent. So when you add that, that is when you add 40 plus 320, you get the answer as 360 grams. Okay. And now, once you got the mass of solution, because for the formula itself has mass of solution in it, mass of solute and mass of solution, because you didn't knew what is the mass of the solution, you have to calculate that by adding mass of solute plus mass of solvent. right? So when you have to calculate the mass percentage of solution, it will be like mass of solute upon mass of solution into 100, like whatever answer you get, that is 40 divided by 60 into 100, and then you get the answer as 11.1 percentage. So this is how you calculate mass by mass percentage. If you have to calculate mass by volume percentage, you're going to use the same formula that has been given, and for volume by volume percentage you will use the same. Got the thing? So I just want you all to like solve one same thing. Okay, but I'm changing the value over here. Wait. Instead of 40, let's do it 80. Okay, so I have changed it to 80 grams now. Now calculate and tell me the answer, like what will be the answer for it. I hope you all are calculating this. Now instead of 40, you have to calculate it for 80 grams of common salt. I hope you all are calculating it. So when you calculate it for 80 grams, this will change. It will become 80 grams plus 320 grams. Now what is the answer for 80 grams plus 320 grams? 400 grams, right? So when you calculate it, it becomes 80 divided by 400 into 100. And you will get the answer as 20 percentage. Got it? How will you calculate? Now this will be multiplied by 100. Okay, so this is how you will get the answer as 20 percentage. Now I hope you are clear with, like, if you get any of the example on it, or if you have to calculate the concentration in terms of mass by mass percentage, mass by volume percentage, or volume by volume percentage, you will be able to solve it on your own, right? So now I want you to like even write this example in your book, or for 31. I hope you all are writing it. Okay, I hope you all are writing it. So I'll stop over here for today because we will be discussing about like suspensions and colloidal solutions in the next part. But make sure that you are understanding the solute, like this numericals, how to do it. Okay. It's just that you should be able to identify what is given, what needs to be calculated, and you should be knowing the formula to calculate that, and then done. Now, after this, in the next class, I will be starting with suspension, where we will be discussing on the properties of suspension in detail. After discussing the properties of suspension, we will even discuss on the Tyndall effect, like what exactly Tyndall effect is, okay? And then we'll discuss on the properties of colloidal solutions as well, and you'll come to know what exactly colloids are in detail, okay? Then after that, we have like few of the common examples to discuss. Then we'll discuss on separating the components of mixture, like how exactly we can separate the component of mixture. We will study that in detail as well. Okay, and here we have like different methods to separate the components of mixture, which includes evaporation, centrifugation, separating funnel, sublimation, chromatography, distillation. So these are some of the methods, but you don't have all the like methods to discuss on. Okay, so we'll discuss on like how can we obtain colored component, that is dye, from black or blue ink, and that we will be discussing through this activity 2.4. So it means, and shortly while we discuss about this activity, we will be discussing about evaporation in detail. Then we'll discuss on like how can we separate cream from milk. Okay, then this is again going to be an through like going through an activity, and then we'll discuss on how can we separate a mixture of two immiscible liquids. So we will discuss that through an activity along with the application part. Okay, after that we'll discuss on like how can we separate a mixture of salt and camphor. So here we will be studying about the sublimation process. So in short, like through activity we will be discussing on different methods which we can use to separate the components of mixture. Okay, then after that we will be discussing on like is the dye in black ink a single color or it is made up of many different colors. So we will study that through chromatography technique. So we are going to study about different methods over here in detail. Okay, after studying chromatography, we will discuss on like how to separate a mixture of two miscible liquids, and we are going to study that like through the process called as distillation in detail. So here we will be studying about fractional distillation, simple distillation, and all. We will discuss in detail about them. Then we'll discuss on like how can we obtain different gases from air. So we'll be discussing on that as well. Then we will discuss on like How can we obtain pure copper sulfate from an impure sample in detail? Okay, so we'll do that in the next part as well. So we'll do it through the process of crystallization. So in short, while we discuss that, we will be discussing on the process of crystallization in detail. Then we will be discussing on the applications as well on it. Okay. Then after discussing all the methods, we will be discussing on the physical and the chemical changes in detail, like what exactly they are. In detail, we'll study all of them. Then we'll discuss on like what are the types of pure substances and can we further classify them as elements or compounds or not. So we'll discuss about elements in detail, what elements exactly are. We'll be discussing on the physical properties of metals and details, and when we study about metals you will get an idea on like the physical properties of non-metals as well. Okay, then after discussing about elements we'll discuss about compounds as well, what exactly compounds are. After compounds we have this activity to discuss, and then there is a differentiating table to discuss between mixtures and compounds. Okay, so we'll do that as well. Then we'll discuss the summary discussion in short, like what exactly we have studied in the whole lesson. So this is how we will be completing up with the lesson, that is matter around us pure. But after that we have 11 exercise questions to discuss on. So I'm going to share you the screen one by one, and I want each one of you to please go through them properly. Okay, please go through the questions thoroughly so that you are able to answer them at the end. So these are the 11 questions that we will be discussing after I complete teaching you the whole concepts on this lesson. Is matter around us pure? And then there's a small group activity that they have given. So this is how we are going to end up with the lesson. Is matter around us pure? Okay. And after this, we will be starting with the next part, but before that, let us first complete with it. So I hope whatever we discussed today, you are very much clear with it. Now the rest of the part which has been left, okay, I'll be discussing in the next class. Thank you everyone.